Good morning and welcome to vSphere Replication, the technical walkthrough. We're going to get started in a second here, so I'll take the opportunity to introduce myself. My name is Ken Warneberg. I manage the technical marketing for some of the business continuity products at VMware. Site Recovery Manager, vSphere Replication in particular, which are the pieces that we'll be talking to today. And this is my colleague Alexei, and I'll allow you to introduce yourself.
Good morning, everyone. My name is Alexei Pershin. I'm an engineer working on SRM, more specifically on pieces that integrate with vSphere Replication. So
today we'll be talking about vSphere Replication in a lot more detail, going into how it's used as a product in its own right, as well as use by Site Recovery Manager. And Alexei will be getting into a lot of the internals and the details about how vSphere Replication works. I want to encourage you to ask questions as we go through. We should have a little bit of time at the end for questions as well. But I would ask, if you're close to a microphone, please use the mics, because it just saves me having to repeat the question and gives us a little time back. And also, if it's a fairly long, technical, sort of detailed question, let's hold those off until the end so that we get a little more time to cover the material off. So vSphere Replication was introduced with Site Recovery Manager version 5 last year. It's designed as a software replication engine that's built into the platform. It works basically at a SCSI filter level. It's part of the hypervisor. It's not an agent that we need to install or anything along these lines. It's directly built into the platform, and we just simply deploy a couple of appliances in order to manage the replication that it does. Replicates individual virtual machines. It's not the same as array-based replication where we have a data store, we're replicating that data store or a LUN or a disk group or anything along these lines. It's a VM by VM replication engine. We can set properties for individual VMs or groups of virtual machines. Because we work at this vSCSI filter layer, because we're working at the hypervisor layer, we're operating above the storage but below the virtual machine, which means that we have the ability to replicate between dissimilar or heterogeneous data stores. We're not operating at the data store level. We're not working with snapshots or CBTs or anything along these lines. So we can replicate between just about any type of storage, the VSA, local storage, NAS, SAN, whatever we've got, irrespective of what that underlying technology is. There are a couple of things about this. We have asynchronous replication. It has the opportunity to choose a recovery point objective between 15 minutes at the most aggressive and 24 hours at the other end of the schedule. And recovery, testing, various pieces in terms of that automation of the recovery was introduced strictly through Site Recovery Manager. So SRM layers are on top of different types of replication, array-based replication or vSphere replication, and then SRM acts as the orchestration tool that will go through, run our test recoveries, run our actual recoveries, all the rest of those components. So that's how it stood in 2011 when we introduced the technology. And the architecture looks a little something like you see on the sides here. From an SRM perspective, we need to have two different SRM servers paired with a local vCenter server. And across sites, we have to worry about replicating the data. We can either, again, do this at the storage level, or with vSphere Replication, where am I? Up here. So the way it works is that with SRM5 and the initial release of vSphere Replication, we would deploy two appliances, the vrms, vSphere Replication Management Servers. They act in essence as the interface between SRM and the agent. It doesn't partake in the replication or participate in and of itself. But what it will do is have a database that handles things like the replication RPOs and various other components that SRM needed in order to make sure that they were being replicated on an ongoing and correct fashion. But then there is the VRA, which is the agent. It sits within the kernel, within the vSphere kernel itself, and operates at the vkernel level. It really consists of a couple of components. Picture a filter that is tracking the blocks that are being changed as they're written to disk, and a scheduler that handles determining when it's time to take the pointers to those changed blocks, gather them together in a bundle, and ship them across the wire to the VRS at the remote site, the vSphere Replication Server. So the VRS does nothing other than grab those blocks and write them down to disk using network file copy down to the storage layer. So this is the architecture of vSphere Replication that we introduced with Site Recovery Manager version 5. Very early audience participation moment. Could I get a show of hands, everyone who is using SRM today? Nice. Those of you who are using array-based replication, and those who are using vSphere Replication. We've got about 10. That's about 6 more than we had yesterday, or the day before. So hopefully this will give you a lot more detail then about how vSphere Replication works, why we think that this is a really excellent replication option. And I say option very carefully because we're not replacing the capabilities of storage or array-based replication. It's designed to augment it. If you have tier 1 workloads that you put on your replicated SANs, that's perfect. But not everyone can justify the bang for the buck of putting all of their virtual machines onto that expensive replicated storage. So you can now tier out the replication options with Site Recovery Manager using array-based replication and vSphere replication. Other people might not even have multiple arrays, let alone the replication engines and all the rest of those pieces that go into that. So now you have the capability of doing replication within the caveats that we have, 15-minute RPOs, and we'll talk a little bit about application quiescing and things like that. So if these caveats around this are sufficient, then you can use vSphere replication alone in tandem with array-based replication. It doesn't particularly matter. The idea is that we've got options now in terms of how we want to replicate our data between sites for use with Site Recovery Manager. So on Monday, what we announced is that we've taken that vSphere replication engine and we've decoupled it from Site Recovery Manager. It's now a feature that you can deploy if you have vSphere Essentials Plus all the way up to Enterprise Plus. It's included with your licensing. You can deploy and protect virtual machines using vSphere replication as you have the rights to do that with your licensing out of the box. So now you have the capability to get some of this protection, but not the orchestration and the recovery testing and the reporting and all those components that Site Recovery Manager gives us. Whoops, didn't mean to do that. So this replication engine is now with the platform. It's bundled with most of the additions. I encourage you, when 5.1 is actually released, take a look at it. You can replicate between clusters, between vCenters, or within a single vCenter itself. You can replicate a virtual machine from one location on disk to another data store or whatever it happens to be. So even within a cluster, you have a local copy of your environment ready to be recovered. So this standalone vSphere replication, I use that term to differentiate it from that which comes with Site Recovery Manager. It's the same replication engine. We still bundle it with Site Recovery Manager, but you can install it as a standalone tool, as it were, as well. It's a simple recovery model. It's tightly integrated with the web client. You can very easily go through and select one or more virtual machines, choose to replicate them and protect them to some other location, and then recover them. And the idea is that with vSphere replication as a standalone entity, you recover them one by one. So it's not like Site Recovery Manager where we can have these complex orchestrated recovery plans that will, in a planned and pre-tested fashion, do a whole bunch of virtual machine sequencing and things like this. But we can very easily right-click on the shadow copy of the virtual machine and recover it in a matter of minutes with a handful of clicks. So simple per virtual machine recovery on it. VR also supports automated reprotect and failback workflows when we're using Site Recovery Manager. So in the past with SRM, we introduced this concept of reprotect. We could fail over the entire environment or a subset of the environment to another location, and then simply click one button, and it would reverse the direction of the replication and protect the environment back to your primary site in an automated fashion, setting you up to do a failback in a very simple fashion. But that was only supported with array-based replication. As of the current version of vSphere replication, we now support that same functionality, those same workflows of reprotect and failback for vSphere replication, even, again, mixing and matching vSphere replication and array-based. So with SRM, we have that capability. We simplified how it gets deployed and configured. I showed you that architecture with two VRMS components and one VRS component. Those are just the appliances that we need to deploy. We simplified that dramatically, so it's just one appliance. Especially with the vSphere replication as a standalone entity, you simply deploy one appliance to act as both the management framework and the target for replicated blocks, and you're done. It's a very easy, simple process to get this up and running. As well as including an embedded database. In the past, we would support Oracle, DB2, SQL Server. We can still use those options if you want an external database, but we can also use the integrated embedded database that ships with the VRMS as well to obviously have some implications in terms of licensing costs and manageability and things along those lines. The VRMS and VR server are combined into a single appliance, as I've mentioned. We no longer have to deploy all those different components. We can just deploy that single, simple appliance, and we're off to the races. Application quiescing, we've made some changes in the way we do that. I wouldn't say this is really new code or anything along these lines, but what's happened here is that we've more tightly integrated with the capabilities of the VMware tools that have already been doing application level quiescing to get a slightly better level of consistency in our data, and I'll talk to that in more detail. As well as some performance improvements in the way we do things like our synchronization of our virtual machines and the data therein from one site to another. So let's talk about it with regards to Site Recovery Manager. As mentioned, it's now independent. We can install it as its own component without SRM, get it up and running, get our machines replicated, take a look at it and say, yeah, this is working for me, this is great, and then simply put Site Recovery Manager on top of it, if you choose to go to the SRM room. It will leverage, or it will use those replications that have already been configured. We can add them to protection groups and then start doing recovery plans around those replications that we're doing with vSphere. It can replicate, as I mentioned, within a single vCenter. If we deploy just that one appliance, it will act as both the management framework and the target. So we can choose to replicate from one location, send the change blocks up to that simple appliance, and have it right back down to the same cluster in a different location, giving us a local copy that can be recovered in a matter of minutes. And when we install SRM to layer on top of this, it will discover all those replications. It's very straightforward, and Alexi will go into a lot of the detail about how those replications work in a couple of minutes. So what do we get by moving from the, as it were, free edition of vSphere Replication and moving up to Site Recovery Manager? Lots of things. Automation, test recoveries, reprotect and failback, customizing things like network and running scripts and generating reports for audit trails and all the rest of those things that Site Recovery Manager has always been designed to do, giving us that capability. And as I mentioned, we can have standalone vSphere Replication, we can have SRM, we can layer them both together, we can have one or neither. It doesn't particularly matter. They coexist quite happily, or they don't coexist quite happily as well. So the new architecture looks like this. We have a single VR appliance. Whoops. No, go back. German-Canadian hands and tiny buttons. So we have a single appliance that we deploy now. It's paired up with a vCenter server. There's only one appliance, and it can only be paired with one vCenter server. So we can't deploy more than one VRA per cluster, or per VC, I should say. But when we deploy multiples, we can use them as targets for the replication. As a virtual machine writes down to disk, so we're passing through the hypervisor layer, the vSphere replication agent will detect that it's writing. If it's configured for replication, it will detect that it's writing, and we keep track of those blocks that are being written to disk. We don't actually copy those, we don't use change block tracking or snapshots or anything, we just keep in memory and in what we call a persistent state file, pointers, as it were, to the blocks that have changed. Then according to the replication schedule that we've set up, periodically we will grab this, according to the scheduler that, again, we'll be seeing a lot of detail on, grab those blocks that we've pulled together, create a lightweight delta, create a block bundle, as it were, ship that across to the remote appliance, and write it out via network file copy to the location on disk that we need. So it's a simpler architecture than we had with the previous sets of appliances that we had to worry about. And if we're using SRM, we can actually add a handful of more appliances to distribute the loadout among the different appliances that we've deployed. We don't have that option with the standalone component. You don't really need it. It supports up to about 500 replications with that one appliance. So in terms of configuring it and the deep guts of it, I'm now going to hand it over to Alexi, who's going to walk you through a lot of the very, very interesting components of it. And as I mentioned, we can take some questions as we go, and by all means, feel free to ask.
Thank you, Ken. I'm going to walk through essentially the lifetime of a virtual machine, from the moment you configure replication, how it lives through the cycles of replication, to the recovery side, and what happens to it when we recover, test it, and even when we go back as part of the failback workflow in SRM. In the beginning of all of this comes the step when you have to configure replication. And as Ken mentioned, vSphere Replication is built into the platform, so it is integrated in the vSphere UI, and configuring replication is as easy as finding the virtual machine in the VC inventory and right-clicking on it and saying, configure vSphere Replication. After this, you walk through a simple wizard which asks you things like what kind of RPO you want, what kind of quiescent level you want, and you also ask where you want to replicate your virtual machine. And you can choose the destination per virtual disks, or you can even drop certain disks from replication. What happens if you have more than one virtual machine to configure? In this case, you can obviously go click 111, but it's a bit tedious if you have a few hundreds of those to go through. Obviously, you can go to the UI, right-click on all virtual machines that you want to replicate, right-click and say configure them all. In this case, the wizard is kind of similar, except that the RPO settings and quiescing settings will be applied across all the virtual machines in this particular set. The destination, you can choose to replicate to the same data store, or if you want a little bit more complicated setup, you can configure what we call data store mappings in advance, which essentially you say that data store A on protected side gets mapped to data store B on the recovery side, and then data store C gets mapped to data store D. And after this, if you go through the multi-VM wizard, all the VMs that are sitting on data store A will be automatically replicated to data store B, and then VMs from data store C will be replicated to data store D. This is also available in our UI, configure it in advance. Another nice feature of vSphere replication is that we allow you to seed the initial copy on the recovery side. The basic use case of this is that if you have a very large VM, terabytes of data, and you multiply it by 100, so that's quite a bit of data to replicate, especially over WAN. If you want to save on that replication over network, all you can do is you can download the virtual machine files on some storage, hard disk, USB drive, DVD, we don't really care, and then literally ship it to the other side via FedEx or put it in your suitcase and carry it yourself. And then on the recovery side, you import it into the some of the data stores that you want to use. And after this, you configure replication to those VMDK files as a target. In which case, the vSphere replication will determine that this is exactly the same disks, figure out which blocks are changed, and ship the changes over to the other side. You don't really have to be very precise. You don't have to make sure that the VM doesn't change while you are trying to establish seeds. The more recent the copy, the better. The less blocks you will have to replicate over the network. But even if it's 1 or 2 months old, we don't really care. If you're using the multi-VM version of the replication wizard, it's a little bit tricky to configure initial seeds. Basically, you have to put the virtual VM files in a specific way on the target data stores. And how to do this, please refer to the administrative guide for the vSphere replication. Now that we covered the UI portions of it, let's talk a little bit what happens inside once you configure replication. The first thing we do is we do what we call the initial sync. We go to the target, we look at the VMDK files that you gave to us, and we compare the identities of those disks to make sure that those disks are actually the same disks. They don't have to contain the same blocks, but at least it's the same disk. We don't want you overwriting some other VM VMDK just by accident. If the disks are the same, then we are going to read the blocks on the target side, read the blocks on the source side, calculate essentially hashes on both sides, and then exchange the hashes to know which blocks are different. This way we avoid sending all the blocks over. We only send the change blocks that were missing in the initial seed that you provided for us. In this example, as you can see, you have blocks A and C that are already present in the seed disk, and then we determine that blocks B, D, and E needs to be replicated, and we replicate them. And after the initial sync completes, we have an exact replica on the other side.
I just want to jump in for 1 second here as well. The seed copy is a great way to save on bandwidth and time for that initial replication, but it's not required. If you don't have a seed disk, you don't have a copy at the remote location, you can just go through the same process, and obviously the hash comparison will be very straightforward.
Right. I also would like to mention that this process, we call it full sync, really. We use it every once in a while if something happens to the replication, somebody modified the target disk, for example, or some kind of error is discovered that we cannot recover. In this case, we say, okay, we cannot track the change blocks consistently, we have to do full sync. In this case, the process is the same, but obviously we don't replicate all the blocks again. We just do the hash comparison again. This initial replication traffic goes over a special TCP port 31031. So if you want to distinguish between initial syncs versus ongoing syncs, you can actually configure different quality of service in your routers depending on the port. Another important piece of vSphere replication is what we call light-well deltas, which is essentially similar to a VM level snapshot, but it is not a VM level snapshot. The reason we don't use VM level snapshot is because they do have performance penalties. The VM needs to be stunned, which means that there is short stoppage in the services in the VM. If we have to create a redo log on top of the existing VMDK files, that's a performance penalty associated with that. Instead, we create what we call the lightweight delta or lightweight snapshot, which acts essentially as a snapshot, meaning that it's a consistent point-in-time image across all the virtual disks in the VM, except that it's not a VM level snapshot. That means the I/O is not penalized. VM works just as it were before that. There is no penalty associated with that. And once we created the lightweight snapshot of the source VM, we know that this is the consistent image. And we use this information to transfer the ongoing changes according to the RPO schedule that you send to us. And essentially, for every sync cycle, we create a lightweight snapshot, and between them, we track what's changed, and we replicate just those blocks. So as you can see in this example, we determined that between the sync cycles, the source virtual machine changed blocks A, C, and D. We detected that, and we transferred that to the recovery side to make them the same. Notice here that the block A actually has two indices at the bottom, which means that this block may have changed twice or even more times within sync cycles, in which case we don't replicate it twice. We replicate it only once, whatever the latest version of that block is. And as I mentioned earlier, this ongoing sync traffic goes over a separate TCP IP port 44046, which allows you to configure different quality of service or bandwidth controls in your routers based on the port.
Before we carry on any further, any questions about that? Anybody have any sort of... Okay, there's a question up here.
What happens if the source disk is modified, like if you grow the disk?
The question is, what happens if the source disk is modified, if you grow the disk or make changes in terms of the UID or anything along those lines?
This is one of those changes that we cannot use the filter level tracking for, so in which case we initiate a full sync, which is the rescan, calculating the hashes, and changing the change blocks over. Once this is done, then we go back to the normal lightweight snapshot kind of syncing.
The real danger is if you make changes that will actually change the disk ID. That's when you're really out of luck.
But you're still doing the change, you're still just shipping the change block.
Yes, we are still just shipping the change blocks. After it does the full sync is still, it only works in terms of change blocks, end of story, all the time. The full sync is just that it's calculating what the full change blocks are for the entire disk as opposed to what has been driven through the SCSI filter. That makes sense. One more question, yes? Will it work with storage DRS? So with version 5, it does not, and there are a couple of reasons for that in terms of what can happen when you do a vMotion. It might trigger a full sync if we don't pull that persistent state file across with it. We've made some changes in this version. We're still undergoing testing to make sure that nothing is going to break. It should work, but at this point, we're going to say that it's not supported because we haven't done the full extensive testing against it.
Yeah. Let's talk a little bit about the what we call the lightweight delta protocol, or LWD protocol. This is our proprietary protocol that is used to send replicated traffic from the vSphere replication filter in the SCSI level, in the SCSI stack in the ESX. The traffic goes from the filter to the vSphere appliance on the other side. This traffic is effectively just change blocks with some metadata associated with this. As I mentioned earlier, this traffic goes between two different ports for initial replication and for ongoing sync, so we can do different quality of service based on that. Let's talk a little bit about the consistency guarantees that vSphere replication provides. At the bare minimum, vSphere replication provides you a point-in-time specific consistent replica based on your RPO. This replica is going to be crash consistent, which means that the write order is going to be preserved across all virtual disks in the VM. So whenever we started the sync, this is line in the sand, and all the writes that happened before this line in the sand, they would be in the replica. All the writes that happened after this line in the sand, they would not be in the replica. This provides the crash-consistent view of all the virtual disks in a given VM. On top of this, we can add additional level of consistency. If you turn on the guest level quiescing, in which case, while creating lightweight delta, we actually go talk to the guest and ask the guest operating system to flush the file system, in which case the replicas are going to be file level consistent. And in this version, as Ken mentioned, we're also adding the application level consistency, in which case, as part of creating each lightweight snapshot, we actually go talk to the guest and talk to databases that are available in the guest to ask them to flush, which uses the VSS framework in Windows, which quite a few databases support, Microsoft SQL Server, Exchange, things like this.
So I want to clarify one thing here as well. We are doing VSS writer flushing, so we are asking those applications to dump their writers and so forth, but we aren't doing things like log handling, so we're not doing truncation and log rotation and things along those lines. It's a VSS copy, but not a full VSS copy, if you know what the difference is in terms of those individual components. And when we talk about application consistency, as Alexei mentioned, every disk within a virtual machine will be write consistent within the lightweight delta that we ship. But we don't do cross-VM consistency in terms of vSphere replication. So if we've got VMs that are codependent on in terms of write order fidelity and things like that, and VSS application and log truncation and things along those lines, you have to be very cautious about how we use it in those scenarios. Sorry.
Okay. Let's talk a little bit how we protect against network failures. If you imagine a very simplistic algorithm where we have a set of VMDK files on the recovery side as a target, and then we start shipping the change blocks over, and in the middle of this, network drops, and suddenly we didn't finish the sync cycle, in which case the replica would be inconsistent. In fact, it would be invalid because there's no consistency guarantees at this point. Obviously, this would be bad. So to avoid this kind of behavior, what we actually do is on the recovery side, we snapshot the target VMDK files. And for every sync, we're actually writing to the redo logs on top of the replica. So this way, essentially what happens is, as we detain change blocks, we ship it over the LWD protocol to the recovery side. They get written to redo log on top of the actual replica. And once both sides agree that the sync cycle is complete, then the redo log gets flushed to the actual replica. What this gives us is that once the initial sync cycle completes, we always have a valid replica on the other side. It doesn't matter what kind of network failures you have. We always have at least one.
And when we're talking about snapshots, keep in mind, we're not talking about the VMDK level snapshots. What we're talking about is really just the collection of blocks that we're gathering before we write to the VMDK at the recovery side. It's not a VM level snapshot. And the other question that comes up a lot, I'm just going to cut you off here and throw you questions on the fly. What happens if the network link does fail in between? And we're in the middle of shipping blocks. We've got some at the recovery site, and then it goes away. Are we then invalidated, and do we have to start over from scratch? Do we have to do full syncs? This one comes up all the time as well.
The answer to this question is actually we are doing the smart thing here, which is if the network drops in the middle of a sync cycle, the recovery side VRS appliance knows that there's some blocks written to this redo log on top of the replica. At the same time, the protected side filter knows that it hasn't shipped all the blocks. So which basically invalidates saying that this sync cycle failed. At this point, we are not going to discard the tracking of change blocks since the previous sync cycle. We'll just continue on as if this cycle never happened. And because of the scheduler, the way it works, I'm going to talk about on the next slide, essentially, the scheduler most likely is going to initiate the next sync cycle almost immediately because the previous one was close to the RPO. A question. Let me finish this and I'll answer your question. And essentially, the new sync cycle is going to write to the same redo logs. And because the blocks are going to be the same, so it's going to get the same blocks there. And once it completes, it's going to get flushed.
That's the question. The question is, when if that link does go down, is it the source or is it the target that says, I'm not receiving replication, and then reinitiate the synchronization after the link comes back up?
The answer to this question is that all the decisions when to do replication cycles is done at the source side by the scheduler. So if the filter in the middle of the sync discovers that the connection dropped, most likely it's going to be by timeout or some kind of network failure, it will tell the scheduler that it didn't finish the sync. And at this point, the scheduler will do the smart thing to recover.
One more question, yes.
Are the blocks that are copied retained?
Are the blocks that are copied retained? So if you mean during a half sync, as it were, when the link goes down?
You copy a bunch of blocks, but the sync doesn't complete. You retain those blocks and these blocks. Is that so?
They are retained, but the filter is going to send the same blocks over again. So only for this particular sync cycle.
As Alexei said, we pretend that one never happened because we don't know the state of that data at the recovery site. So
right. And the reason for this is because you cannot guarantee, the filter cannot know that the last blocks it shipped actually were written, because the network failure may not get the confirmation correctly. So we have to reship it. So although it's only within this sync cycle.
Again, it's just delta, right?
Right. So it's not a question. Okay, now let's talk about the scheduler. This is the central piece of vSphere replication. It runs on each host. And what is it for? What kind of problem it's trying to solve? Imagine that you have one virtual machine. It's configured for some replication parameter, RPO, let's say 15 minutes. So the most simple algorithm is that every 15 minutes, you come in and initiate a sync. You complete the sync. You wait for the next 15 minutes. You do another sync. Now, what happens if you have 1, 2, 3, 100 virtual machines? What if you started a sync that takes a lot of bandwidth, take a lot of time? And during this cycle, the RPO time comes in for the next virtual machine, but the bandwidth is not available. So what are you going to do? Are you going to wait until that sync cycle completes? But in this case, you're violating the RPO. So this simplistic approach doesn't really work efficiently. Instead, what we try to accomplish is we essentially try to predict the future. And the way we do this is it's easier to demonstrate on the graph shown at the bottom of this chart. Essentially, the horizontal lines here, they represent replication groups or virtual machines. Each bar is a sync cycle. The height of each bar is the bandwidth that this particular virtual machine needs to use to send over the replica. The length of the bar is proportional to the amount of data that need to be replicated for this sync cycle. And how far apart they are spread out, this is essentially the RPO settings. And then at the bottom of this chart, which is the bandwidth heat map, the red sections represent high bandwidth, and the green or yellow sections represent low bandwidth. Essentially, what we do is we look into the future, up to 48 hours, and we use the historical information from the past replications to estimate how much bandwidth and data for each virtual machine we need to replicate. And then we essentially put all of this onto a schedule map. And since we know how much data is going to be replicated, so we can see that at some point the bandwidth is going to be used, so we can move some of the replications earlier to free up the bandwidth, even though it means that we will be replicating not at every 15-minute RPO, maybe we'll replicate maybe at 10 minutes, but at least we'll be minimizing overall bandwidth used by this host. And as you can see here, you see that some of these replications, they're kind of moved a little bit earlier, specifically to accommodate large syncs. And as I mentioned, this scheduler runs per host. It runs across all virtual machines replicating from this host. And the problem that the scheduler tries to solve, it minimizes the overall bandwidth usage across all replicated virtual machines on that host while satisfying the RPOs for all virtual machines.
Okay, let's start. Are you done with that one? Because this one went on for a long time the last time. So I saw you earlier. Yes.
The VR agent for each host manages the replication. What does the motion occur as long?
Yeah. The question is, this is a per host heat map, as it were, a scheduler that we're talking about. So if we've got a virtual machine that's sitting in one location and all these calculations are being done, and then we vMotion to another host, then
in this case, the scheduler and the filter, they know which host the virtual machine is sitting on. Obviously, while you're doing vMotion, we cannot do a sync cycle because this would interfere with vMotion. But we keep track of change blocks, so we don't need to do a full sync after vMotion completes. If vMotion takes a significant amount of time, most likely what's going to happen is that once you vMotion VM to the other host, the RPO is going to be either close to be violated or it's maybe already violated. So in which case, the scheduler will notice that, and it will recalculate the schedule for that particular host with all the existing VMs on that host, and will add the new VM, and it may result in almost immediate sync after vMotion is complete. And this will result in all the VMs kind of shuffled around to accommodate the new bandwidth that's required to do this.
I would also like to point out the persistent state file. Where so the reason why it's usually fine, and it's only if you're talking about massive changes during a huge vMotion that you might run into that scenario. We keep track of all the change blocks on disk in this, what we call the persistent state file. So that's going to be there and it's going to be represented even regardless of where you vMotion it. So yes, we'll have to do some recalculation on the new host in terms of what its scheduler looks like, but the blocks themselves are still being tracked. Yes, there's a question here. Can you limit the bandwidth that vSphere Replication uses over the WAN? Not with vSphere Replication itself. You can do some things in terms of QoS. You can do some vSwitch level QoS implementations, but you really have to do that at the target side. The idea is really that we wanted to leave this as an open thing. If you're talking about cross-site SRM type of implementations, a lot of the times there will be some absolutely great traffic shaping utilities that you're already using in terms of compression and encryption. So it's not encrypted, it's not compressed, and we don't really, inherent to vSphere Replication, put any type of throttling or anything in place around it. Yes, question here. The question is, can you control the point in time at which the syncs happen? No, that's why the scheduler handles all of this. That's why we generate this whole algorithm to track the heat maps and determine. So it's not a point in time type of a replication at all. It's on and being scheduled in this fashion, dynamically moving things around, or it's not. Yes? The question, sorry, the question is, where is the change block log in essence being retained? And it's in a couple of locations. I'll let you get into the details.
The key piece that keeps track of what's changed is the vSCSI filter driver that sits on ESX in the kernel mode, right, essentially underneath the virtual machine. This is the piece that tracks what's changed.
So we track it in memory in the host itself, as well as putting the pointers to it in the PSF file.
Right.
Yeah, the question is in terms of how does that basically get flushed in essence? How do we then track that what we've shipped? Are you adding IOPS and workload basically fundamentally to do the tracking? And the answer is no. We're tracking just what's being written, just pointers to those disks, and we're keeping basically those pointers in memory and in this PSF file. But we're not intercepting that I/O. We're not doing a copy on write or anything against that. What we're doing is just seeing which blocks have changed as they're being written, not intercepting them or anything along those lines. There is some very, very minor overhead associated with the host with that process on the order of maybe 2 to 5% performance hit at most. But it's very marginal because it's really just a couple of blocks in memory and the scheduling process that needs to worry about. Sorry, I will come back to you. Yeah, there's one more. Will this work with raw device maps?
The answer to this question is yes and no. It depends on what kind of RDM disks you're using. If you're using physical compatibility RDMs, in which case the I/O goes directly out of the virtual machine into the array that is back in the RDM device, in which case we don't see it, so we don't support it. If you're using RDMs in a virtual compatibility mode, in which case the I/O actually goes through the vSCSI stack in ESX, in which case we do see this I/O, we do track this, and we do support it. Moreover, we support it not only on the source side, also on the target side. You can actually replicate from a virtual compatibility RDM on the source to virtual compatibility RDM on the target. But they don't have to match. You can replicate for RDM to a VMDK and vice versa. So, but it has to be virtual compatibility RDM.
We've got about 20 minutes left, so if you don't mind, maybe we can just get through a couple of more slides on the presentation, then we should have a fair bit of time left at the end to kind of tackle some of the more detailed types of things that we got.
Okay. Now that we covered the sort of the replication configuration step, the replication life cycle, now let's talk a little bit what happens during the failover and test. If you initiate a failover, what we essentially do is we take the VMDK files that we created on the recovery side and we surface an actual VM out of them. And we register it in VC and power on, and this becomes a VM. In addition to this, we actually collapse all the redo logs that are present in the replica files to avoid a constant performance penalty associated with redo logs. If you're using SRM, you also have the ability to perform a test, in which case we essentially perform the same steps surfacing the VM, except that instead of collapsing all those replica redo logs into a single VMDK file, we create a snapshot on the side. And this is a real snapshot, so the VM is writing to it. So VM can be runs perfectly fine. You can write to it, you can modify it, you can reboot it, everything works fine. However, at the same time, the replica files, they live their own separate life, which means that the replication continues on, it doesn't stop, but the VR appliance on the recovery side actually knows which particular replica was used to create a test VM. And it keeps it always, it never collapses it so that the VM never loses its base. Now let's talk a little bit about another feature of SRM, which is called reprotect and failback. Essentially, the idea is that if you have an actual disaster, you might fail over to the recovery side. But actual disasters don't happen very often. In fact, most of the time, the disasters can be predicted. Hurricanes, for example, power outages that PG&E tells you in advance. In which case, your production side, even though it won't be functional for a while, it's actually working perfectly fine. So in which case, you can initiate a planned migration to the recovery side, shut down your protected side, and just wait until the hurricane leaves or until the electricity gets turned on back on. After this, you can power on your protected side again, and now you want to go back. In this workflow, which we call the reprotect, essentially we go back to vSphere replication and ask it to configure replication back from the recovery side back to the protected side. And in fact, at this point, when we did the initial recovery, we actually left the files for those VMs sitting on the protected side. And when we configure replication, we use these files as seeds. And what it means is that after you did the reprotect, there will be initial thing that determines what actually changed since you initiated failover and the VMs were running on the recovery side, and only the change blocks will be sent over. It will not do the full terabytes of data transfer over the network, which means that after reprotect completes, there is a relatively short period of time where we're doing all this resyncing, but after this short period of time, your recovery side will be fully protected back to the original protected side. In fact, at this point, the roles of sides switch. What used to be a protected side becomes a recovery side, and vice versa on the other side. Once reprotect completes, you can initiate a failover back to the protected side. What's cool about this is that you don't have to do it in one go. You can actually do a test going back to make sure that it will actually work, because you never know. If the test succeeds, then you can do the full failover to the other side, and after this, you're back to normal operational state. And then you can do another reprotect to flip replication back to the recovery side, and this time, everything in a state as if initial failover never happened. And at this, I pass the button back to Ken.
Okay, back to, okay. That looks like a good slide. Oh, wait. This, as I said, we would have some time left at the end for questions. So the summary, vSphere replication decoupled. Not interested in the questions? Okay. vSphere replication decoupled, very cost effective, very easy to adopt and deploy. There are lots of new features in terms of the integration with SRM, this reprotect and fail back process, interaction between, really vSphere replication is now at a full par in terms of the feature set, in terms of Site Recovery Manager. The application level quiescing has been improved, really taking advantage of the platform capabilities and the VMware tools that we've gotten there. Much more approachable. Two other things, I write a blog on our vSphere blog called Uptime, and I have a Twitter account at VMKen, where I post a lot of these types of details that we've been talking about today. I just want to make sure now we get lots of time for questions, so I'll shut up and go to the guy in the microphone because he stood up and went to the microphone. Thank you.
Thank you. Quick question. When you choose to replicate a VM, can you choose a subset of the VM decays within it? For example, if it's a C drive only that you need to copy, instead of like the E and F or whatever?
Yes.
The answer to this question is yes. You can do this. If you use an SRM, it can go a little bit further than that. You can, let's say if you're using a swap disk that you don't want to replicate, in which case you can pre-create a VM decay file for that swap disk on the recovery side. And you can tell SRM to attach this VM decay after the failover, in which case you don't have to go back to the VM and create a VM decay, reconfigure the swap stuff, and all of these things you need to do in the guest. It will be done completely transparent to you as if it were replicated, even though it wasn't.
Gentleman over here.
So in terms of network design for this, what exact VLAN, what exact network interface is the data being moved over? Is it like when you put is it the VRA is a virtual appliance that sits in there, and whatever VLAN you connect him to is the one that the data's pumping over?
Yeah, the change blocks themselves are actually being generated by the kernel, so they're being shipped out by the VR agent across the VM kernel port. So you can separate this out and create a dedicated port group for that traffic, but it has to be a VM kernel port group, and then you have to do things like add static routing because it needs to be able to resolve the appliance on the remote site. So your VM kernel network needs to be able to resolve it and ship it directly from the kernel over to that remote site. Sorry, yes?
If we ship a seed off to our DR site, is the seed encrypted?
I'm sorry, what was the question again?
If we seed the other site, ship a USB drive, whatever, is that data encrypted?
The answer to this question is it's really up to you, because we are not, if you're seeding the files, you're the ones who are copying the files from protected site to some hard drive, shipping it over, and importing it into the vSphere. If you want, you can encrypt the hard drive. It's really up to you. All we are asking you to do is point to the actual imported VMDK on the other side. How it popped up there, we really don't care.
So we put it like on an NFS mount point or something like that to get it.
Yeah, we can give any, we can put the seed in any location at all. We will write to that location regardless of what it is. The only thing that matters is if it's the same disk ID. That's it.
Okay.
Right. Yes?
Can you quickly just highlight for me if there's any differences between, say, using vRanger Replicate as compared to the vSphere Replicate, if you're already using that?
I don't think it would be fair for us to comment on other people's technologies. Really, I mean, this has been around for over a year. And the fundamental goal initially was to integrate this with SRM, to give us an option at the SRM level. And now it's detached. It is what it is. It does what it does. So I don't think it would be fair. Sorry. Thanks.
You're agnostic as far as the storage, but you're agnostic as far as the VMware tools requirement. So it doesn't matter if it's Linux, Unix, any other type of VM.
If you're not using guest quiescing, in which case it doesn't matter what kind of guest it is, because we're sitting right outside of the VM. It could be DOS for all we care.
VMware tools, VMware hardware is actually important for this. We need to be running VMware hardware version 5 and above, I think it is.
Yeah, it has to be one of the latest
7
virtual hardware version. for the all the infrastructure to work correctly.
Perfect.
If you're using guest quiescing, then it has to be Windows, it has to be VSS. For app-level quiescing, I believe it's Windows 2008 and Windows 7. So it has to be one of the recent Windows versions for this to work.
So we have like lots of software load balancers that are Linux-based kernels that don't have VMware tools as an available plug-in for it because it's not responsive to that. Are those still able to be moved?
Yes, you'll just lose app-level quiescing, but the replication will work, and it will still be the crash level consistent, even if there is no tools inside.
The hardware is the important part.
Right.
Yep.
Yeah, in terms of the WAN, is there any latency cap? Maybe it can be contributed by any reason, right? From the source to the destination, like protected site, for any reason, the latency can go up and down.
Can I jump on this one?
Oh, right.
And I do have a second part of the question. Does it try to reconcile any kind of I/O controls from source and the protected site?
Right. You can tackle the whole thing because I'd have to hand it over to you halfway through.
Okay, so the vSphere replication doesn't have any caps on what kind of latencies you have, what kind of distances you can have. We work with whatever network you provide to us. In fact, if you remember the slides for the scheduler, we actually learn what kind of network you have, how much time it takes to replicate a certain amount of data. However, it doesn't mean that you shouldn't care about this. And the answer is yes, you should, because latencies and the bandwidth available between sites fundamentally determine how much data per hour, per minute, per second we can transfer over. So for example, if you have a very, very narrow pipe, but your protected site generates gigabytes of data per minute, this data cannot possibly squeeze into that pipe. And this is what we call the replication cliff, where as the amount of data to be replicated increases, the moment it reaches the theoretical maximum that can be squeezed into a pipe, you're going to get RPO violations because there's no magic. We cannot just squeeze it into the pipe. So
the bandwidth is far more important than the latency, but the latency does contribute to it as well because obviously if there are delays in getting the data across that big or small pipe or whatever it happens to be, it will eventually creep up and start causing problems. But the bandwidth is more important, and I'm just going to jump in here as well because this one comes up all the time. What sort of bandwidth do we need for vSphere replication? And the answer is who knows? I mean, it depends entirely on a few factors. What are your RPOs? How many virtual machines are you replicating? And what's the what's the churn rate on your data for those virtual machines? And I'd be surprised if more than 25% of you actually know what your churn rate is on your data in the room. It's just it's a very difficult thing to track on an ongoing basis. But that's why the scheduler is so dynamic and tries to learn these things and move them around to try to fit within those RPOs based on the bandwidth that you give us. So we don't have any particular requirements in that space, but you'll get what you get based on the network that you got.
and if you do get the RPO violations, they will show up as warnings in the UI, and you can actually configure events and alarms for them. So this way, you can get an email if you get an RPO violation.
We'll come back to the other one too if you need to. So yes.
Well, two questions. One, so is it agnostic to provisioning type? If I do thin provision disks, it still works? Everything's good?
Yes.
Okay,
yeah,
good.
it works fine. You can actually mix and match between sites. You can have thin provision on one side, thick on the other side, however you choose.
And on the target side, the implication is that for each replica, you keep it around for a while because I can stand up a machine from a replica. So once all the blocks are copied over, are they applied, or do you have this kind of history of points in time that you can go back to? Or is it just always the last point in time that's completed?
There's always one consistent image, and then there's always one consistent redo log. And that it's only once that redo log is completed in terms of the shipping and the acknowledgement has gone back and we all agree that that gets applied to that VMDK. But we don't keep a history of VMDK redo logs or anything to choose from in terms of recovery.
So you get the latest one. Any plan to add some sort of, just kind of keeping...
The feature, yeah, I mean, we're aware of the requirements of our customers. So yes, we're looking at ways to do that, absolutely.
Great,
yeah.
thanks.
Yeah, I had a question on the networking side. Do you allow any controls for the scheduler as to when to do replication windows, anything like that?
No, not really. No, it's entirely about the RPO's decision-making process about when to ship the lightweight deltas. It'll always move things up. It'll never move things back in terms of crossing a violation. Like, well, we'll just send that one later. It only tries to move things forward in most occasions. But it's not designed to be do replication between 11 o'clock at night and 3 in the morning type of a thing. It's a turned-on replication because You might have a crash in the middle of the day. Again, the history is that this is a disaster recovery tool where we want to have most recent possible data.
The other related question is there's an extended network outage. What happens to your filter and the tracking? Does it, how much time before it gives up and said, I'll do a full sync when it comes back?
The answer to this question is that we don't give up. So the amount of data that we need to keep to know which blocks changed is minimal. It's essentially a bitmap of all the blocks, and it's very small. We can keep this bitmap forever. At some point, you're going to get RPO violations, you're going to get emails if you configure them, but we will know what's changed.
You can manually go in and pause the replication and stop it, but if you haven't done that, why would we? Yes?
If you're managing multiple sites with a single vCenter server, can you still do replication?
If you're managing multiple sites with a single vCenter server, yes, you can. You cannot replicate from one vCenter using the standalone vSphere replication, as it were. You can't. The key comes down to the appliance, basically. So we can have one appliance per VC. So if you've got 5 sites all managed by, if you've got 5 sites all managed by one virtual center, that's fine. Because the replication is coming per host and out of the VM kernel, it's just going to send it to the target, which is the appliance, and it'll write it out to whatever destination has been configured for it. But because it's one VC per appliance, we can't do back and forth, and we can't do hub and spoke and star and cascading and all the rest of those types of things, because it only has that one destination. With Site Recovery Manager, it's paired, or end-to-one shared recovery model, so then we can deploy the one appliance per VC, then we've got at least 2, and then we can deploy those additional appliances as targets as well. But it's still a paired or a shared recovery model with Site Recovery Manager.
Thank you. Is there any limitation on kind of storage I can use, like share or?
I'm sorry, is there
any limitation on what kind of storage I can use, like iSCSI?
Nope, doesn't matter at all. We're operating above the storage layer. So we're just writing to VMDKs. Where they reside, we don't care. We're tracking as they're being written to VMDKs, and we're then writing to the VMDK at the recovery location. So no limitations at all.
You can even use local storage, SATA drives attached to ESX.
USB drives.
USB drives, whatever, it doesn't matter. So you literally can have a single Dell box on the protected side and a single Dell box on the recovery side and replicate between the internal drives.
And now I have to say we're not tied to Dell.
All right.
Yes.
Yeah, is the scheduler or the mapper with the heap of bandwidth, is that at all visible to the end user? I know we can't schedule it, manipulate it aside from the RPO, but can we actually see what the schedule might look like the slide presented?
Don't think so.
You can change RPOs, you can look what the RPOs are, but you cannot actually see the schedule. If you go to the UI, you can see when a replication was done for any particular VM and how much data it transferred and how much time it took. That information is available, but in terms of this kind of graphical map, no.
Yes.
Can you talk a little bit about a prerequisites on what we would need to run this new vSphere replication? Because it's built into the hypervisor now. Do we need vSphere 5.1, or if you were to buy and go with SRM 5.1, do we get this added functionality?
Yeah. So to use the, let's call it standalone version for lack of better terminology, you need to be running vCenter 5.1. It only interfaces with the web client, and that's the end of it. From a host perspective, it's 5.0 or 5.1 or any update thereof, because it's part of that agent that is part of the vSphere 5 hypervisor. Okay. So it's backward compatible. That's not a problem. With SRM, so you can install it. You install VC 5.1. You've got the bits there. You just deploy that one appliance, and you're off to the races. It will auto-register itself as a service in the web client with vCenter, and you're done. With SRM, we also include the bits, as it were, with SRM, so you can install it via that plugin as well, which only uses the C# client still. So it's a matter of deploying the OVF through the SRM plugin interface if you're doing it via SRM. But you can deploy it via vCenter 5.1 and then layer SRM in and then take advantage of what you've already put in place, if that makes sense.
Thank you.
Welcome. Yeah.
If we convert the hard disk from a thick disk to a thin disk, will it stop the replication, or will it do a full synchronization again, or it just do the replication just the changes? So if I do a storage vMotion and if I want to change it from a thick disk to a thin disk, which is like a replicated disk, and if I change it from thick to thin, will it stop the replication and do the full sync again, or it just does the change block?
In this case, this transition from thin to thick actually happens transparently to vSphere replication, so we don't need a full sync. We just continue tracking.
Okay. And also, like, we don't need any free space or anything on the data store level, right? To keep the LWD, the lightweight snapshots, we don't need any space on the data store level, right?
The lightweight snapshots, they're actually not on disk. The purpose of them becomes to...
All right, let's carry on our conversation outside.
Right.